observation. Although, is that a matter of also the physical shape and size? How I mean, you're there doing the research. Would it be possible to get, say, 95% of the brain under monitor through your array?
We're lucky with the system we're working in that most of the cells are on the surface of this brain.
Oh.
So multi-electrode array technology, for the planar multi-electrode arrays, the one big limitation is that you can only record on the surface of the tissue you're looking at. We might, if we wanted to get, a very large percentage of the brain, we might have to start using another technique. And there are a couple other techniques in development, a couple of which we'll be looking at over the next few years. So voltage-sensitive dye recording, where you actually get this optical signal from the brain, allows you to go deep. And there have been a couple experiments in invertebrates that people have had some success with this.
Ah, okay. So the new hardware that you had mentioned just a couple of minutes ago, that perhaps would be some of the new hardware coming online that could allow a deeper analysis of the brain.
That's still a planar system.
Oh, it is. Okay.
Yeah, but we're looking at doing some combination techniques as well. So that maybe using that planar multi-electrode array with voltage-sensitive dye, or possibly coming in with some other types of electrodes from the other side of the brain at the same time.
Okay. Yeah. And as far as your future research, I mean, what you've been doing so far with the arrays and analyzing the snail brains, I mean, it sounds like you're going to stay on that path, basically speaking, for the next couple of years, let's say, and continue working with what you're familiar with, the snail brain?
So my primary research partners, it looks like from the position I'm in now, I'm actually now employed fully by the Department of Informatics at Sussex.
Oh.
So I'm still going to be doing some management of the multi-electrode array lab, but and partnering with the people that are working there. But really my primary role now is software development and data analysis for this system.
Okay.
And some of the other people that I work closely with in the lab that I'm now paid by are also doing human level studies, so fMRI and EEG data. So depends on how busy I get, but I'd like to apply some of the stuff I'm doing, or try to apply some of the software to EEG or fMRI data as well.
Yeah, and now, what is the different type of data that you get out of fMRI versus your direct electrode approach there, or is it very similar, the neuronal activity that the information that you get out of those two methods?
They're very different.
Oh, they are quite different. Okay.
Yeah, very different. So in fMRI data, you're actually looking at a voxel. You're looking at a visual representation of, it's a three-dimensional voxel, and they're much larger. So you have much larger spatial resolution and temporal resolution than we do with the electrode arrays. The advantage with the fMRI is obviously you can cover literally the entire brain.
Okay.
If you want to, but you're going to pay for it by, and it's much more expensive technique and a much slower and much larger spatial resolution than you would get with multi-electrode arrays. But there are some people doing what they call ICE, intracranial electrophysiology, in combination with fMRI, and that's very interesting. So this is where they get somebody who's maybe a patient who has epilepsy, and when they go in there to actually do surgery to find where the focus of their epilepsy is, they'll convince that person to sign up for a research experiment, and at the same time they're doing the surgery, they can do intracranial recording on them and possibly fMRI at the same time.
Oh, interesting. Yeah, and at this point I was just going to pause for a second to remind the audience members that are here tonight, we've got a big group here, to ask any questions that you might have about the neuroscience applications, the brain-computer interfacing, and the multi-electrode arrays here that Peter has been researching on. A good point to pause here, because I was going to start talking a little bit more about some of those other research initiatives that are going on in the world that are kind of related to Peter Peter's work and his views on longevity science as well. So remember, if you have any questions, just go into the text chat and ask them, and I'll take a look and pass them on to our guest here tonight. And as I mentioned, Peter, I wanted to ask you about some of the other initiatives that revolve around brain-computer interfacing and reverse engineering of the brain. What do you think of the Blue Brain project? I'm sure you're familiar with that.
Yes. Now, what do I say about Henry Markram? So I'm very excited about the ambition of the project, and you can't underestimate it because that project has a tremendous amount of money behind it now, and a tremendous amount of commercial research or interest as well behind it from IBM and other partners.
Yeah.
But it is extremely ambitious what they're going after. So my perspective, as you can presume now from the system I'm working in, is that I wanted to come at it from the other end of the scale. I wanted to be able to completely understand a very simple system before trying to move on to higher level systems. But their approach might be the way to go. So they're doing more of a top-down approach, but it is extremely comprehensive what they're doing, and he has a very large team working on it.
And the type of data that you generate from your research about neuronal activity and structures in the snail brain, is that the type of basic data that the people at the Blue Brain would incorporate into their neuronal models in silico?
They might. So their primary model is the rat.
Right.
The one they're working. In general, as I understand it, how they're working is they're using a large amount of biological data. It's mostly intracellular recording from a few cells.
Mm-hmm.
What they've done is they've built up a large number of models of individual cell types from the rat brain. And they've started assembling these model cells in ways that are very similar, or as close as they can get to what's known about the structure of the rat brain. And so eventually, what their hope is to build out the whole system. And they're starting in a very good way. They're going after one cortical column, which, if they can model that will provide a tremendous amount of useful information for neuroscientists working on cortical structures.
Yeah, it does seem like they are making some progress, and I suppose from your perspective too, it's amazing the amount of funding they are able to generate for their project.
The Swiss government and IBM and some of their other industrial partners, yes, they have a tremendous amount of support.
Oh yeah, they certainly do. Well, and another research effort that I'm aware of that has gotten a lot of media attention there in the UK that you might be familiar with, and guests that we've had on the program in the past, is Kevin Warwick. I believe that's from the University of Reading. Are you familiar with his cyborg experiments?
I am very familiar.
Oh, okay. And at the time, 2 years ago, well, about a year and a half ago, he had mentioned he was going to do a direct brain-to-brain implant experiment with himself and some research assistants. But I never heard anything about that. I wonder if it was put on hold. Did you hear anything about that yourself?
Well, so I have to be very delicate here.
Oh.
But I would say that not to expect much out of Kevin Warwick, ever.
Okay. I was wondering maybe about that. He certainly is a good publicist. I will say that.
I would say that if you look, he has absolutely no publication record, as I can detect, in the last 10 years.
Okay.
And he gave a talk here at Sussex, must have been about 8 months ago or so.
Uh-huh.
And there was he said some things that were pretty disingenuous here. So I highly doubt it. I would doubt anything that comes out of his lab at this point.
Oh, okay. So I shouldn't get my hopes up too much about that. I would say Mr. Warwick certainly is daring as far as doing experiments upon himself. If